मधुर मनोहर अतीव सुंदर ये सर्व विद्या की राजधानी राजधानी।
Well, my dear students, we are going to start electronic courses sponsored by Ministry of Human Resource Development Department under a mission program on education, which is called as National Mission on Education using Information and Communication Technology, New Delhi. It is sponsored by MHRD, New Delhi. The purpose of these courses are to prepare electronic version of different courses so that it can be helpful to all over world through internet and through web. So, with this purpose, we are going to start the e-course on mechanics of metal forming, and this whole series of the lectures, that is audio video lectures, would be hosted on internet by MHRD department with the help of IITs and all other agencies. So, the purpose of this kind of course is to give overall picture of the course, and this includes around 40 lectures with audio video inputs, plus the 4 coordinate system which has been suggested by the MHRD, that includes the question answer by the user once the whole course is delivered, and it includes the feedback of the users with the people those are going to present the lectures, and plus whatever real life classroom lecturing is done, it could be put into the format of this kind of e-course. So, we have planned accordingly as per the instruction, and we are going to present before you all dear students this particular course, mechanics of metal forming. So, with this starting, let us see what is mechanics first, because once we understand what is mechanics, then we can correlate with metal forming and all those things. So, in a very rude way one can understand that in a very concise manner. So, fundamentally any area or discipline that deals with forces and their responses may be called as mechanics. That means we have mechanics of solids, like we have mechanics of fluids, like one also come across the mechanics of structure, mechanics of politics, mechanics of economy, mechanics of biosystems, and likewise, and particularly this course, we have then mechanics of metal forming, etc. So many likewise. So the whole mechanics, in fact, if you see, it can be further divided into three main branches, like the statics, dynamics and kinematics. Kinetics also and rigid body kinetics also are the part of the mechanics itself. So if you look at the mechanics, so that is the statics part. So what is statics? So statics deals with the study of bodies at rest where no change in momentum occur, whereas dynamics concern with forces and matter with a change in momentum has to be there. And on the other hand, kinematics is a mathematical area, which is a mathematical way to describe motions without regard to the forces present over. And if you see the kinetics, which deals with the physics, that is the study of motion and its causes, and rigid body kinetics like then is the study of motion of rigid bodies therefore. So in fact we are basically concerned in this particular course with rigid macroscopic bodies, not microscopic. So microscopic point of view we would be dealing in this particular course. Therefore this mechanics, that is the metal forming. Now the second part is the metal forming. So what is metal forming and what it concerns? So in fact in metal forming there are four things to remember always. Number one, the space, that is the workpiece, and there is always a workpiece. The work has to be shaped in some form, some size, some contour like that. So this particular workpiece requires a space, and you have to fix this workpiece in somewhere on which the forces are to be applied and the proper toolings, with proper tooling, and so the deformation take place, and so there must be a space, first thing. Secondly, the workpiece itself, as I said, that means where the workpiece is distinguished with the behavior, because the two body would be in action, one the workpiece itself and another the tool. So the tool is going to work along with force, through force, and it has to come on the workpiece. The workpiece has to be loaded. So workpiece acts as a slave and tool acts as a master. Third thing is the time, for how much time and in which sequence this time is distributed. So the time is to relate the sequence of events on the workpiece, so that it is converted from initial shape to a final given shape. The last one which concern and is important is force. So force is an essential agency which changes or tend to change the state of the body at rest or uniform motion of the workpiece or a body. So that's the force. Force may be of different type. It may be sometimes torsional force, it may be sometimes tensile force, it may be sometimes compressive force, it may be sometimes combination of all these forces. So therefore the aspect of metal forming require, what are the things? it requires the material. If you look at this figure, the metal forming is a process. So forming is a process. So that has been shown, the rounded one portion where the process, and this process requires three things, as I said: material, that is the workpiece material; the press, that means a means where by which you are going to apply a force. So the press, it may be a hydraulic press, it may be a mechanical press, and then there is a die. So the whatever shape you want to give to the workpiece, it is to be kept through a die, which is sometimes it is a supporting die, and the material also has got a tool. So these are the three input for the process, and then finally you get the finished product after the process is taken, has completed. So that's how you have the material in the form of workpiece and tool. Secondly, the machine, which is press or hammer. Third, the tools, that may be dies or other toolings. And the fourth, the operation, that is the process itself, like extrusion process, forging process, rolling process, or cupping process, quinning process, ironing process, upsetting process, bending process, explosive forming process, and so many. There are varieties of processes it can be. So look at this figure. This is a usual figure where the blacksmith most often come across. This guy is striking a red hot workpiece, and is striking with a big hammer. So it's a kind of hot forging process. So whereas you look at the second part, it is a manually, this one is the manually. On the other hand, this is being shown with the rotating arrangement, where the flat punch and the flat die is there, and it strikes like this. So it can be a part of a power hammer, and there is a tongue which is holding the workpiece, and it can be rotated. So you can see here, so it's a head of the hammer, and the rotating tongue which is holding the workpiece is used for very fast, so the productivity increases. On the other hand, this case is again a forging, but it's a bulging process. So that's a bulging process where you have, and other example of the forging. Now look at this case where you have a situation where you have a sheet forming with the help of bending. So there is a mandrel, and then there is a roller operated tool, and it is holden, the workpiece is arrangement which is being held in the tailstock, and then with the roller tool it is being shaped over the mandrel. So this is also a kind of forming process. Now look at these figures. There are 4 figures: hot extrusion, drying is. So this is the deep drying operation. You look at here. So the things has been drawn. That is the hot extrusion case, where the dies, and then it is preheated. The workpiece is preheated. You can see these are and the billets. The billet is going. It is the stock of billet here, and these stock after preheating, it is coming out of the preheat furnace, and it is ready for loading on the extrusion press. So you can see it is now coming out of the hot furnace, and it is going to be loaded in the press. Now it has been loaded, the hot billet, and the punch is going to press it. On the other side, you will see on the back of the machine, the after extrusion, it is being pushed, the hot billet is being pushed by the ram in extrusion machine, and it is now coming out, and that is the puller which is pulling the it is called as the, here it is the multi-stage wire drying, where a particular cross section of the wire is reduced in multi stages. So it becomes much more thinner. You can see long sequence of the stages of the wire, and each station there is a die, and it comes out. So from one stage it goes, and then next reduction, next station it comes out, and finally it is being wrapped in the final place. So this is what is being wrapped finally here. So once the dimension is reached, and look, the other example which is hot forging here. So there is a bigger hot billet, red hot billet. There are people around, and there is a pressing machine, that is the that is the press, and the two people are holding with the hot billet and rotating with the tongue, and it is being pressed. So it's, now you see the sequence of and the speed of hammering, and also simultaneously it is being rotated. This is very important, at what speed it is being hammered, so that there is no defect comes into, and you can look into here, the people are around, and it is strike from hammer also, rotating, and then so many, it's a big job. So most of the heavy duty forging is carried out like this, manually and simultaneously with hammer. So see, again there is a control of the ram of the hammer for controlled striking on the billet. It is actually, it is being produced a billet which would be further converted into a ring one. So it is still, now you will notice the speed, notice the rotation, the tongue, and the heat itself all around. So the place is very hot. Now it is ready for another strike. So it is again, you see the whole the small droplets of the these material, it is coming out after the forging, and this is very important. Now you see, notice that shape that is going to change. It is going to change a very round and with a very specific contour on the sides. So it is simultaneously, it is using the barreling. So at the edges the things are being barreled. This process can also be, it produces flash, but here when it is in closed die forging, then it is called as closed die forging, where the flash is also controlled. Now this is ready for ring. So a punch is placed inside at the middle, and then again it will be strike. Now you look at, so it is being again strike, so a hole is created, and once this hole is created, this punch will be taken out. You look at, so now this is taken out, and now this will be elongated. This ring will be, this punch, the hole which has been created will be used again for, so the diameter of the punch will go on increasing, and later another tool will be kept, so that we can increase the, see, the another die to increase the diameter it is, and then it will again be taken out, and so it goes on number of times. So the again bigger hole will be created. Now you see the sequence, it's the sequence is very important here. So it's all part of shaping, part of the operation of the forming. So now you look here, still it is going on, and this is what is the beauty of forming. The process becomes so important that the costs associated, the time taken, and the material property that you are getting, it's the material becomes very strong because of inherent hardening, and then later also for further hardening. So you look at here, again the things are still going on, and the enlargement of the dia is and then there is a rotation simultaneously, then the removal of the scales are to be done at the, this is at the final stage. So, so the final diameter has to be maintained, and that is what is being created by rolling, revolving it around a mandrel. So, the simultaneously the scales which has been formed during the operation, that is also being removed. So, you, and it is so peculiar process. So, once it is done, the workpiece is taken out. So, now we can answer what is metal forming. So, metal forming or metal deformation is shaping a given metallic workpiece or an object by applying external force that you have already seen. That is in equilibrium, the forces, and it can be done by varieties of ways so as to get the desired shape and size of the product by variety of processes, as I said. You have also seen, like you have a cold, it can be done in cold, so and it can be done in the hot, as you have seen. It can also be done warm forming, where we take the advantages of both cold and hot by by the processes like extrusion, wire drying, rolling, forging, sheet metal forming, etc. So, with the application of load to the workpiece, onto the workpiece, internal stresses and displacements are generated, which causes shape distortion, and if the loads are very low, then with the release of the loads, the internal stresses will disappear and the workpiece will be restored to its original shape in case of elastic deformation, and so are the stresses and strains. Elastic strains are recoverable on release of the load with the and when the loads are high enough, the chance of changing in shape will be is not going to disappear after the load is released, and that case becomes a plastic deformation, what we call. The change in the shape and the strain, those that did not disappear, namely therefore that is a kind of permanent one, and that is how it is called as a plastic deformation. That is that inherently it will retain. During metal forming by bulk plastic deformation, bulk means when the deformation is very large as compared to the elastic deformation, so we call it as a plastic deformation. In bulk metal forming, the plastic deformation are much higher than elastic deformation, which is and therefore the elastic deformation can be ignored, and it is also ignored. Thus, only plastic deformations are considered for most of the bulk metal forming processes. It is also recognized that plastic deformation do not involve volumetric change. Thus, volumetric constancy rule is there, and that is maintained. In metals, the load and the intensity of the internal stresses at which plastic flow initiates are in fact function of the structure, the temperature, the deformation history, how it is done, it has been done earlier, and the rate of straining, that is the strain rate. It is assumed that at temperature below the recrystallization temperature at which the new crystal structure emerges, the material strain hardens, but it is not strain rate sensitive, and therefore the strength of the material increases with increased deformation level. Above the recrystallization temperature, the material is strain rate sensitive, that is its strength is higher with the higher rate of straining, but it does not strain harden. The point in loading where the incipient plastic flow commences is therefore called as the yield point, which is very important. We would discuss the yield point, the theory of yielding and all those things later. A deformable material is said to be perfectly plastic material. If you recall the work by Talbot 1984. So when we will call, that is the deformation is perfectly plastic material under three situations. Number one, the material is incompressible. Secondly, there exists a material constant K, capital K, with all kind of material, and with the dimension of the stress, and thirdly the stress deviatoric, what is the stress deviator on the strain rate. Okay, so what is the hydrostatic stress, what is the deviatoric stress of the total stress, we will discuss later. So with this background, let us see what are metal forming processes now, because it is a part of the topic of the course, and also it is the first lecture. So now with this particular background, let us see what is metal forming processes. Friends, large group of manufacturing processes in which plastic deformation is used to change the shape of metal workpiece. The tool, usually it is called as a die, and the die applies stresses that exceeds the yield point or the yield strength of the metal. The metal takes a shape which is determined by the geometry of the die, therefore. So the overview of the metal forming process involves, number one, the material behavior in the metal forming, temperature in the metal forming, strain rate sensitivity, and friction and lubrication in metal forming, especially in cold case. Stresses to plastically deform plastically deforming the material are usually of nature compressive in nature, in forming. Like if you see the rolling process or forging process or extrusion process, these involves compressive stresses. Stretch, that is the stretching kind of force, like when you stretch the metal, like tensile stresses, like the bend the metal, like tensile and compressive simultaneously, and other types also comes, like the shear stresses. So there are processes correlating with. For example, if you see, for forming desirable material properties, whenever you form, you require certain desirable material properties as well. So the material properties that we expect after forming, that with the workpiece, that it should have low yield strength and high ductility. These properties are in fact affected by temperature. When work temperature is raised, that is the workpiece temperature is raised, ductility increases and yield strength decreases. Other important factors are also considered, like the strain rate, friction, and all those things. Let us see this figure, this slide, where the deformation is carried out in one direction only, and that is what is a very popular example, where this is we call as the tensile test. So you look at this here, it's a tensile workpiece, a standard tensile workpiece, where the diameter is D0 and gauge length is L0, and it is stretched in a vertical direction by force F, tensile force F. After deformation, the diameter becomes d1 when it is still in the elastic limit, and once the necking is start, when that is the instability, once the material reaches at the instability point, so necking is starts and the diameter becomes d2. And finally, one further, because the strain hardening takes place and you require more and more stress for deformation, and when the necking takes place and finally when the final diameter df is reached, that's the fracture, and immediately after that the fracture takes place. So these tensile tests are used to draw a stress strain curve. First we draw the load displacement curve, and using that one can draw the stress strain curve. So here if you look here, this is just for showing you the three diagrams A, B, C. In A, that is what is being shown, the stress in kilopascal, and here it is the strain. So one can see the yield point, ultimate tensile strength, and the fracture strength has been marked. And other hand, for the other kind of material in B is shown, and the C, where it has been shown the point A and B. So the A is up to A is the elastic limit, and B it is what is the plastic limit, upper plastic limit, and then one can find out the stress as force by initial area, and that can also, and the strain. We in fact define the two kinds of so when we draw the stress strain diagram, there are two types. The engineering, we call it as the engineering stress, one can say it capital S, and that is the what is being shown here, the engineering stress versus engineering strain, and that is very popular for ductile material. And secondly, it can also be drawn it for the brittle material, which has been shown in B, case B. So for the brittle material, and the plot C, it is replotted as converted into true stress and true strain. The true stress and true strain is the incremental form, because instantaneous. So that is what is the very basic. We would be dealing these things in detail later. So if you look here, these are some of the processes again to show you. This is what is the rolling process, the two rollers. It is a two high rolling mill kind of, and this is the what is the load created by the rolls, and this is what the opposite nature of the rolls, and this is the what is the workpiece. So the initially it is a dragged in, and then it comes out after the rolling. So you note the height of this slab, so it is reduced. This case is the extrusion, direct extrusion process, where the force, this is what is the ram, this is the die, and this is what is the workpiece, and the material comes out after extrusion. This is what is the die, closed die forging. You see here, this is the closed die forging, this is the workpiece, upper die and lower die, and the force F, and this is the flash comes out, as I mentioned earlier also. This is what is the wire drying. So wire drying is the initial wire is fed in the die, and then it is pulled on the other side. In the extrusion, it is force is applied from the pushing, and where it is in the wire drying, it is a drying force. So there may be back tension, but this is what is the pulling force is required in wire drying. These are another set of the process forming, where you make a cup. So this is a cup forming, where these are the punch and blank. So this is initial blank, and this is what is the blank holding. Blank holder is important to reduce the wrinkle and all those things. So, and there is a die, so the punch will slowly, and generally it is done and at cold condition. So, in all forming processes one has to notice that the product has to come out defect free. If there is at all any defect appear, it is not good enough. So, that is how the is necessary. This is the another situation where it is a bending by a tool is done. So, there is a die again and there is a workpiece and there is a punch. So, a special shape of the punch is there and it is bent, the workpiece is bent in 90 degree. So, that is another example. This is what is the shearing. This is the shearing action where the workpiece, there is a die and there is again punch and it will shear across this here. So, and you see the after shearing how the it is separated. So, a punching making a complete round punch of rectangular punch is a example of shearing. This is what I have shown earlier, where you make use of bending. It is a plate which is being on the tailstock side, it is being fitted and it will rotate, and on the other hand there is a tool. This is the what is the tool and it will be used, it is a bending and rotating. So, it is another kind of forming process. So, if you look at the details of punching, if you punch a rectangular, so this is what is the rectangular workpiece arrangement, that is the whole die and tooling arrangement for creating a rectangular hole inside a workpiece. So, this is what is you see, this is the piercing punch, this is the springs, these are the punch holder, and this is the blanking die, is the saddler, is scrap stripper, blank. So, you notice here these are the different toolings which is further required to support the workpiece, and it varies from different process to process. So, this kind of tooling is the example where you are piercing a rectangular hole in a workpiece. Similarly, the tooling would be separate for extrusion, tooling would be separate for rolling and all those things. So, that is how the metal forming becomes so interesting, so important, and usually it is experience based. A person which is very experienced will do the same job very precisely, very accurately with lower tool and at lower cost as well. Here is another example where the explosive forming we call it as a unconventional forming processes, where the explosives are taken and it is exploded inside a closed packing, and generally it is done in a water. So, this arrangement is for explosive forming. You see the explosive here, and there is again the workpiece, the hold down rings, the die, the vacuum line, the tank where the water is filled, and the water level is always kept at very high level, and the explosives, and then the explosion is created. Because of the explosion, a very high force, the wave, that is a blow pressure wave is generated, and that is what is being utilized for deforming the material with the support of die and vacuum chamber and all those things. So, these are the other varieties of explosive forming where you notice 1, 2, 3 and 4 cases. So, this is what is the pressure pulse is generated in the second one, and is a gas bubble which starts initially and then it forms a pressure, and that strikes on the workpiece here, and the vacuum, because it is vacuum, so this pressure is used to deform the material, and that is the third case where the dome which is caused by the pressure, and this is what is the gas bubble expansion, and this is what the arrangement which is flume which is caused by the venting of the bubbles, and that is the details of one can also design the process for different. The cylinders can also be formed in different shapes with explosive forming. There are many other examples. So with this background, let us see what is the whole course content of this particular course, that is the mechanics of metal forming, for your information. So the whole course has been divided into three basic part. So part A, part B and part C. Part A is introduction to the plastic behavior of metals and alloys. So very basic introduction, including the crystal structure, then the forming, then the parameters that all those things for forming, and then the part B will cover the mechanics part of the plastic deformation, and third part is the modeling and simulation technique. Based on the part B, there are modeling techniques in metal forming processes. So we would be covering in number of lectures. Basically total whole course will be covered into 40 lectures including this lecture. So let us see the part A, what we would be going to have. So it is for your knowledge. So part A, starting with the introduction, like crystalline structure of metals, mechanics of plastic deformation, factors that affect plastic deformation, strain hardening like recovery, recrystallization, and grain growth, and hot forming, cold forming, all those things. Then the flow curves, that is the tensile test, how it is conducted, and then how do we draw the flow curves and our Luder's line, then we the stress strain curve, the true stress and true strain, and advantages of true stress and true strain curve, our engineering strain, the stress strain curve for ideal situation for elastic incompressible materials. Then there are certain deviations in the stress strain curve, we would cover that also, and how much work is done in stretching a bar, and stresses in the neck formation of the flat plate, how it looks like in case of tension, and volume constancy equation we would be covering. Like if you see here, there basically structure, if you see, there are three types of structure: hexagonally packed, FCC, BCC. So this is what has been just shown to you, the atoms, how the atoms are arranged in these three kind of structure. So one can see here, and we would be however covering in detail while and you know the tensile test is very popular in all forming processes. One must know the strength of the material, its ductility point, its fracture point, all those things, so that we can design the forming process safely without defect. So this is how the stress strain curve becomes popular with stress tensile test. So you now look here, it's a stress strain curve for concrete, for cast iron, and this is what is of very important, the mild steel for forming. One can see here as the engineering stress and engineering strain, where the necking here, and you again the strain hardening, and then once the necking start, and then when the drying, and then after necking start, drying happens, and then how the things. So this is what is being engineering stress and strain. So just for example, as you know, if you go into the details of deformation process, usually the whole structure, there are slip lines. So there are slip planes, there are grain, and there are grain boundaries, because the holes are the lattice crystals are there. So these crystals, basic unit is crystals, are separated by grain, that is grain boundaries, and there are slip lines. So the motion of a dislocation, there are dislocations sometimes, and that gives rise to, because of the external forces, motion of the dislocation, and it encounters the grain boundary once. So there is a barrier, because at the boundary, and so the dislocations will change across the boundary, and that is how uh, the the hardening takes place. So all those things we would be covering into detail. In the part B, as the mechanics part, we would be devoting maximum time over here. As you know, the stress of stresses, because there are many type of stresses. So we would be covering the stress at a point, stress circle like Mohr circle, stress invariants, deviatoric and hydrostatic part of the stress, and then equilibrium equations. So like here you see, this is what is the different, it's a uni-axial tension one can across, then biaxial tension, triaxial tension, biaxial tension and compression. So there are variety of the forces that may come in different forming processes. So there is a triaxial compression, pure shear also, and there is a simple shear with triaxial compression. So there are 1 to 11 different ways how the stresses will appear during different forming processes. So we would be the major stress, to understand what is stress and what is, then it becomes the tensor form, and then how the stress can be mathematically represented, and then the whole thing. Then after the state of strain we would be covering. So the introduction part, at the strain at a point, physical interpretation of the strain component, compatibility equation concerning strain, octahedron strain, strain invariants, deviatoric part of the strain and spherical part of the strain, total strain, tensor, the strain transformation laws, and then the generalized Hooke's law, elastic strain, energy, and all those things. Then the basic stress strain relations we would be covering. So starting with the empirical equations and theories of the plastic flow, elastic stress strain relations, plastic stress relations, elastic plastic stress strain relations, empirical verification of the Saint-Venant theory of plastic flow, and all those things. And then the concept of plastic potential, the maximum work hypothesis, the mechanical work in deforming a particular metal, that is the deforming a plastic substance, and then the very important as the chapter on yielding and flow. So that will cover the yield or plastic conditions like your one Mises criteria, and the determination of the constants related, the flow rule, generalized stress strain increment and generalized strain increment, yield surface, Tresca criteria, flow rule, generalized stress strain and generalized strain increment corresponding to the Tresca, and then the yield surface, Hill's yield criteria, flow rule, generalized stress and strain, and then strain increment, yield surface and empirical verification of these yield criteria we would be covering. Then plastic anisotropy, anisotropic yield criteria like Hill's one, the generalized stress and strain increment, all those things. And then there is a lectures, there would be the plastic instability in forming. So plastic instability in forming, like the introduction part, deformation in tension, first necking condition, instability in simple tension, instability of a thin tube under internal pressure, second necking condition, instability in simple tension, instability under complex state of stress, then evaluation of critical subtangent, how do we evaluate, find it out, isotropic material, instability of a long thin tube subjected to internal pressure, instability in compression, instability in torsion, instability of a thin walled sphere under internal pressure, instability of a thin walled tube under internal pressure and axial load, then buckling of compressed bar, plane strain compression, all those things we would be covering under part B. Part C will cover, as I told, the modeling and simulation technique. So popular techniques is starting with the slab method, strain energy, work of the external forces, principle of virtual work, complementary virtual work, method of solution which is based on the principle of complementary virtual work, principle of minimum potential energy, principle of momentum, complementary energy, and then Castiglione first theorem, Castiglione second theorem, Maxwell Barr's reciprocal theorem, Rayleigh's-Reed's method, energy principle in the flow theory of plasticity, principle of maximum work, plastic work, and then the lower bound technique, lower bound and upper bound. Then like the lower bound, when we see in indentation of a semi-infinite body, seat drying through a tapered die, expansion of a thin tube, upper bound theorem, and basics of the finite element method. Very brief we would be covering, because the finite element method now it has become very popular because of its inherent capability and application. And we would be covering the application part of the these limit theorems, like the plane strain compression with the smooth plate, indentation of semi-infinite block by a frictionless plate punch, plane strain drying of a strip with frictionless taper die, plane strain extrusion with frictionless square die, extrusion through a smooth circular die, axial symmetric extrusion, and non-symmetric extrusion we would cover. On the other hand, the next topic that you would be looking into, the slip line field theory. As you know, the slip line theory which assumes the plane strain condition, and so the plane is introduction, and then the plane strain, alpha beta lines, stress equations, velocity equations, Hanke's first theorem, Hanke's second theorem, velocity discontinuity, and stress discontinuities, stress boundary conditions, free surfaces, frictionless interface, and apart from that, frictionless condition, then interface with the sticking friction, then the construction of slip line fields, construction of hodograph, and then the application of slip line field, and then the plane strain compression with frictionless plate ends, all those things, the details which is listed here, and the wedge shaped punch and all those things, the drying of rectangular strip with frictionless taper dies. We will be covering this. So this is what is the part A, part B and part C details. We would be covering this whole series of the topic in 40 lectures. As far as the books are concerned, there are many books. There is no single book that can be followed, and that is how I have listed here a list of books and reference books. So there I have listed here as around 14 such books. So one can accordingly one can choose, like the first one, which is the G.K. Lal book, very popular book, which is the Engineering Plasticity by G.K. Lal and other, which is published by Narosha. Secondly, it is the Plastic Theory, A. Mendelssohn. Thirdly, it is the Engineering Plasticity by C.R. Cadelin and al. The fourth is a Metal Forming, where Witzer, very popular book. The fifth in the Engineering Plasticity Theory by Lippmann. Then we have the Harris book, we have then J. Chakravarti book, we have then Rowe book, very popular book, and Hoffman book, and the Engineering Plasticity by Slater, the Fundamentals of Metal Forming by Wagner and Chenut, and then W. Johnson book, Johnson and Miller, very popular engineering plasticity book, and the Technology of Metal Forming, also Indian version of that, and then the another which is published by the HMT, number 14. So these list of book is very exhaustive. One can select according to the topics, and therefore hopefully you all students would like and you may choose according to your own choices. As you know, the purpose of this lecture is to prepare the e-content, and so that it is useful for all over world, and therefore arrangement has also been made that is for all these lectures that has been delivered now and which will now be subsequently delivered in the next lectures onward. For all such lectures there are questions, objective type questions, basically 20 questions has been arranged. It may be more than 20 also, sometimes 40 also has been there depending on the length of the lecture. So these objective type questions you can answer them and you can judge yourself your understanding. So this is what the arrangement has been made during all these that we are going to deliver in subsequent lectures. So all of you are rather informed by this platform that you can choose this objective question and judge yourself. I will also will request you that you do not forget to give your feedback. There is a provision on the website. When you take this course, you can give your feedback to me so that we can improve upon. You can also give your feedback like what is the quality of the lecture, the voice quality, the slide quality, the material that has been provided, the type of question that has been provided, the video quality, and all those things you can give at the scale, at each you can give at the scale of 5, and the whole thing will be sum. That will help us to improve upon our side, on our side. So I would once again, please do not forget to give your feedback. It is very valuable for us, and at the end I would like to thank you all for your kind patience and for listening the lecture. Thank you.